In this video we're going to be looking at 10.4 angle measures. So our central question today will be, how do I measure and classify angles? How do I measure and classify angles? So let's give a definition for an angle. An angle is the amount of turn between two intersecting lines, rays, or segments. Now, how we name an angle is the vertex, point D is the vertex, is always in the middle. So I can name this angle right here angle EDF or angle FDE. These are both correct ways. If I named this angle angle EFD or angle FED, those would be considered incorrect. So that vertex has to always be in the middle. Congruent angles are angles that have the same measure in degrees. So the angle addition postulate is quite similar to that segment addition postulate. If I add the two interior angles together, they will be equal to the one big angle. When you look at the picture, there should be some kind of sense that this makes. So, if ray AD is the interior of angle BAC, then measure of angle BAD plus measure of angle DAC is equal to the measure of angle BAC. The two pieces, this angle and this angle, should add up to the whole. That's all we're saying. So adjacent angles are two angles that share a side and a vertex. So we can say angle BAD is adjacent to, they share a side and a vertex. So what angle would be adjacent to BAD? If it's sharing a side, this is the side they share, and this is the vertex. Well, they share DA, so that angle would be DAC. Because they both share AD, and they both have the vertex of A. So they share a side and a vertex. So these next words, hopefully we are familiar with. We'll have acute angles, less than 90 degrees. Right angle is exactly 90 degrees. Obtuse angle is greater than 90 degrees, but less than 180 degrees, and a straight angle is exactly 180 degrees. So this is also a line or line segment when it's at 180 degrees. That creates a straight line. So let's find the measure of each angle, just using the information that we know. Okay, so what we can say is, well, if EBF, or if EBC, right here, this little box right here is telling me that that's 90 degrees, and then FBC is 35, what does EBF have to equal? Well, EBF has to equal 55. And ABC is being presented as a straight angle, so we know that's 180. So if this side's 90, what's this side going to equal? Well, this will be a right angle as well, and that's telling me that that's 53. Then this must be 37. So we have it all labeled. Let's see if we can figure this out. ABC, that's a straight angle, so that's 180 degrees. EBC, we have our right angle box, so we know that's 90 degrees. EBF, using our subtraction, 90 minus 35, we got to equal 55. And then DBE, since we know ABE is 90, we can say 90 minus 53 is equal to 37 degrees. Okay, so next we'll turn the page, and we're going to talk about angle bisector. And an angle bisector is a ray that divides an angle into two adjacent angles, meaning they're sharing that side, that are congruent. Angle bisector is a ray that divides an angle into two adjacent angles that are congruent. So we're going to skip these right here, drawing an angle bisector and congruent angles. Let's go down to examples 3 and 4. So the first example for 3. Okay, so QR is an angle bisector. That's telling me it's splitting PQS, QR is splitting PQS into two equal angles. So what is RQS going to equal? Well, if PQR is 37 and these two are equal, then we know the measure of angle RQS must equal 37 degrees. They have to be equal to one another. So, can you try the part B real quick? What is PQR going to equal? using good notation, please. Well, we can say the measure of angle PQR is equal to 23 degrees. Now number 4, I'd like you to try number 4 on your own. Remember, we're just saying that these two angles, if AB, not intersects, but bisects. If AB bisects angle CAD, what can we say about these two angles? So please try this one on your own right now, and then we'll compare our results. Remember that our end goal is to find measure of angle CAD. So just because we find X does not mean we are done. Okay, so hopefully you tried this on your own. Well, we can say that since AB bisects, we can say that these two are equal. So we'll use that idea to help us solve for X. So we'll set them equal, and now we'll solve. I'll subtract 3x from both sides. So I have 2x minus 17 is equal to 14. I'll add 17 to both sides. I'll have 2x is equal to 31. Divide both sides by 2, and we have x is equal to 15.5. Now if I plug in x to either one of these equations, let's see what we get. Well, let's just choose CAB. So I know measure of angle CAB is equal to 5x minus 17. So we'll have 5 times 15.5 minus 17. So when we do that bit of math, we get 5 times 15.5 is 77.5 minus 17. Subtract 17, and we get 60.5. So we found that this angle right here is 60.5. But our question is asking about CAD. So I'm looking for the measure of angle CAD. Well, if this one's 60.5, that tells me that this is 60.5. So to find the two, I'll add those together. And that would equal 121 degrees. Remember, the measure of the angle is in degrees, but x is not. X is a value that we plug in to find the measure of the angle. So these two, so right here, the measure of angle CAB and the measure of angle CAD should both have their degree symbol, but x should not. Okay, thank you very much for watching this video. I hope you have a great rest of your day.